Welcome to Smart Software, a podcast where we talk about best practices in web and mobile software development with a focus on new and emerging technologies. My name is Justice Ethan, and I'm your host today. I'm a developer here at SmartLogic. We're a Baltimore-based consulting company that has been building custom web and mobile software applications since 2005. From the SmartLogic team today, I'm joined by the wizard, Eric Ostrich. Say hi, Eric.
Hello, everyone.
Eric and I are currently in the midst of producing Season 2 of Smart Software, and Season 2 is primarily focused on Elixir internals, so we're talking today about the inner workings of some very popular Elixir libraries, and we're joined by the author of these libraries, Michal Muskała. Say hi, Michał.
Hello, everybody.
So that's my best attempt at a Polish pronunciation of that name. But we're so glad to have you on because you
did good, yeah.
You know, I've heard it said that Polish is a very difficult language for English speakers to learn, so I will take that as a compliment. You've written a couple of really important libraries. You've contributed to Ecto, which everybody knows. You've written JSON, which is, I think, everybody's favorite JSON parser in the Elixir world. So we're going to talk about both of these libraries today. But before we jump into that, could you introduce yourself? Tell us a little bit about your background, the company you work at, how you got started with Elixir.
Yeah, so I'm a software engineer based in Poland currently. And so right now I'm kind of in between jobs, a bit on a fun employment for the summer. We'll see.
We're going to get blown up by recruiters after this podcast.
Yeah, that might not have been very smart to tell openly. But yes, I started with Elixir primarily first became aware of it through some friends at a company where I worked at some point. But later I really got started with Elixir through Google Summer of Code and working on some open source projects. I basically started contributing to Elixir and Ecto and just stayed there. So that was my journey to the language.
So yeah, let's just jump right into it. What part of Ecto did you work on?
So at that, with the Google Summer of Code project, I've actually worked on a MongoDB adapter for Ecto. So I don't like to admit it at this point. Unfortunately, it's after the project finished, it fell behind a little bit because I didn't have a use case for it. But then at some point, both the adapter for Ecto and the driver itself for MongoDB, which was authored by Eric from the Elixir at Hex fame, was adopted by another developer, and he maintains it, both of them currently. But yeah, so during this work for MongoDB, some other elements of Ecto were developed. And I think in particular, the feature that is used the most, which was born out of this effort, were embedded schemas and the way to work with a little bit less structured data with Ecto.
So maybe you could dive into this a little bit. You're writing a MongoDB adapter for Ecto. And so MongoDB is a non-relational database, right? Like, how did you think about the problem? How did you get started? What did the solution look like, especially sort of building on top of, what currently existed in Ecto at the time?
So the first moment when I started with the project, I pulled in some Erlang driver from MongoDB, added it to the Mix project, started the VM, and the only message I got back was bedark, and it shut down. Right? So this was my first introduction to the project. And at that point, I thought, what did I get myself into?
So there was an existing Erlang adapter for MongoDB?
So it was like a raw driver to communicate with the database itself, but it was kind of low level. And so that's one of the reasons why Eric later developed the MongoDB package, which would be like a driver for the database written in Elixir itself. So maybe just for some listeners, I'll clarify what is the difference between the driver and the adapter. So the driver itself, the task of it is to just communicate with the database itself at a very low level, just sending some queries, receiving data, decoding the custom protocol that the database is speaking. And so, for example, some of those drivers for PostgreSQL, we have Postgres. For MySQL, we have MariaX and now MySQL, the new one. developed in Platforma Tech. And so they are responsible for the fairly low-level communication with the database. And then we have Ecto adapters that are responsible for, in a way, bridging the gap between the features that Ecto provides and how do you want to provide those features on a particular database, and how do you want to execute what Ecto provides and integrate it all.
So the first thing you did was you attempted to plug this driver, this Erlang driver, into Ecto as it was set up at the time, and your errors, you get bad arg. Was that a database error that was returning, or an Erlang error, or like what was the problem and how did you solve it?
So this problem can happen if your supervision tree fails at some point to start. Like the VM will fail with a nasty error like that. So it boiled down basically to some misconfiguration that I did when starting this Erlang project. But yeah, so this is where a VM can fail in some cases. I'm not sure it's actually still true anymore. I think the errors during the initial startup were improved recently a little bit. So it might be a bit more verbose, might even give you a stack trace or something like that.
Yeah, I think so. I've recently, like as of yesterday, I'm trying to get something booted in a weird spot, and like all it does is just do a Earl crash.dump with like a single line that's like, hope you can figure this out. So it's, I guess, better and gone nowhere at the same time. So I guess thinking back on this MongoDB driver, is there anything specifically that you would do differently knowing what you know now back then?
So there's definitely, I would structure the code completely differently, right? So at the time I was basically learning Elixir. I knew very little about Elixir. So I kind of was learning both things, MongoDB, or like all the three things, like MongoDB, Ecto, and Elixir itself. So before that, I just played with Elixir a little bit and then contributed one minor feature to Mix. And yeah, so this was my introduction to Elixir. So obviously the code wasn't that great, which also meant it was kind of hard to maintain. And I think one of the reasons why the projects fell behind the development in mainline Ecto, besides the fact that, well, I wasn't really interested in maintaining it.
So we're definitely going to hop into some sort of general, like, contributing to open source projects questions here shortly. But before we do, I want to talk. So first of all, I think this Ecto question is definitely pretty interesting, and we could probably spend a whole half hour just talking about it. But you've written another library called JSON that I'm pretty sure is the default JSON parser for everybody in the Elixir world. Can you tell us about JSON, how you got started writing it? What was the impetus for a new JSON parser in Elixir? Talk to me.
Yeah, so the question about how I got started writing it is a pretty weird. So there is the Erlang has this standard component called leaks, which is a Elixir generator. So you can generate some code for lexing some grammars. You can basically split it into more manageable chunks to later parse it with some parser.
Can you explain lexing to me, like on 5? What exactly is lexing?
Yeah, so lexing is the process. So when you have a string, you have single characters, right? And lexing is basically taking those single characters and putting them into bigger elements. So for example, this is a name, or this is a variable name, and this is a module name, right? So it's still not structured in the classical AST or classical tree you'd have when you parse it, but you have those bigger chunks. So then later when you try to parse it, it's easier because you have less elements.
Is this sometimes referred to as tokenizing?
Yes, yeah, that's true, yeah.
Okay, I feel like I've heard tokenizing in the context of like natural language processing. Okay.
Yeah, exactly.
So go on, you have this lexing tool.
Yeah, so with that old detour talking about the Lexer, the Erlang Lexer works on char lists. And I had a thought one day, what if we could make it work on binaries instead? Would it be more efficient? And how it would work? And so I started implementing actually the Lexer with the working on binaries, which also meant implementing a regex engine to execute it. So a pretty deep hole. But doing all of this, I figured out some couple interesting things about how you could efficiently parse binaries or like most text, binaries containing text, which is how JSON also looks like. And so when I was finished with that project, I had an idea to apply those lessons learned to parsing JSON. And that's how the JSON library was born. Initially, it was actually called Antidote as an alternative to Poison. But yeah, we later decided on changing the name to something
a little too pointed, maybe.
Yeah, exactly.
We're trying to have a friendly community atmosphere in the Elixir window. Bruce taking
exactly. So this was only like a work in progress name.
Yeah. This is the first time I've actually looked at the source code for this library, and it's pretty cool. Like looking at the code gen, if you're interested in macros, there are quite a few.
Eric, give us a little bit of like, what do you see that's blowing your mind right now?
Yeah, so I jumped straight to the decoder, and then I just see there's this byte case, which I'm guessing is most of that work that you were doing instead of working on careless to be on binaries. Is that right?
Yeah, so I built this macro because there is a particular optimization the Beam can do when pattern matching on integers. It can build internally a jump table, which is much more efficient than doing like a binary search or searching between the integers when pattern matching. So this macro was basically to force the VM into using this optimization in those cases. So it figures some stuff and add some additional cases that you probably normally would not use. So yeah, that's the reason to have it. So there's a fair share of meta programming, but there's also a fair share of a lot of source code, which is in a couple places copy-pasted between different versions of decode, especially in the encoder, how you encode strings with different escaping rules. So are they safe to include in HTML directly or safe to include in JavaScript directly? Because it turns out that JSON, the rules between JSON and JavaScript are actually not exactly the same. So that there is case where a string is valid JSON, but is not valid JavaScript.
Is there anybody that's hearing this right now that is surprised? Nobody's surprised that JSON.
Yeah, hopefully not.
JavaScript don't parse. Can we talk a little bit about performance on this library? Because I think your claim to fame is that it is the fastest pure Elixir JSON parser, and you compare it to a native implementation in C that it's twice as slow as the C implementations. So can you talk a little bit about performance, how you got the performance that you did?
Yeah, so it's primarily those binary optimizations, and then also, so when you pattern match on the binaries, the compiler and the VM can do this optimization. Then when you're only using tail calls, they can omit allocating some data, and it turns out that this gives a lot of advantage to when parsing on pattern matching on the binaries. So this, if you look at the source code of the decoder, it's actually all huge. There are just tail calls in there, almost, besides a couple actual parsing, so like converting a string of digits into an actual integer.
Eric, are you looking at that right now?
I am.
Could you maybe talk through a little bit of what you're seeing there as far as what you just said about only using tail calls to get improved memory allocation? So
it's not as much tail calls, but when you pattern match on the binary, so you get like the thing you extracted on the front and you get the tail that you extracted. So what you want to do actually is only use the tail once, and this is to pass it to a recursive call, right? So in this case, the VM and the compiler can skip actually extracting this, and they actually under the hood maintain a mutable data structure for this binary instead of immutable one, but it's kind of not seen at the language level, but then at the implementation level it's there, and it allows for increased efficiency. There's a great chapter about how to leverage this binary optimization in the Erlang documentation, and I'm pretty sure we could link to this from the show notes.
So we don't have video on the podcast, so nobody can see, but Michal and Eric were both smiling when there was this confession of like a mutable data structure below the language level. Okay, maybe someone could share like why that's so funny. Because like I'm smiling too, but I don't get it. So,
well, I mean, like the whole thing behind Erlang is that it's mutable, and like under the covers, they're like, actually, we can make this mutable. So that's like They're lying to us.
Liars. Okay, we've got Eric. Did I miss anything about JSON or actually, Michal, is there anything else about JSON that you think is like particularly interesting that you'd want to share with, especially people who are maybe new to developing libraries in Elixir?
So I think one thing, the area where I'm still thinking about how we could push JSON further, there were a couple of requests about more flexible way to parse data, especially around floats and decimals, because it turns out there are some medical protocols that encode precise decimal numbers as floating point numbers, which doesn't sound like a great idea, yet they do it. And there are also a couple other reasons. So the thing I want to explore would be how we could do one-pass decoding into some higher level data structures. So for example, not output raw maps, then you later have to process again to put into structs, for example, or something like that. But how could we modify the parser to make it both efficient and convenient to maybe output a struct directly, right, as a result of parsing? So this is something I'm actively thinking about right now, and somewhere I'd like to take JSON to.
So if anyone's listening and has ideas, they should come to you on this.
Yeah, definitely.
Yeah. So you're saying
I'm open to hear some ideas around that.
Yeah. So you're saying you can't just set _struct _ to be the struct and make it just works?
So there are more things like that. If you have just one struct, it's basically just that. But if you have nested structs, and then you need to know what those structs are, and then you have a list of structs, and then it can get pretty complex, right? If you get into things like that.
Well, that call for contributions, I think, is a great segue into our next line of questioning, Eric.
Yeah, so we just want to talk, I guess, about open source in general, and you've done a lot, I think. So you've done Ecto, JSON. I think when I was looking at your GitHub profile, there's a handful of others hanging out here. So I guess what was your path into open source? I guess so. We've heard your path to open source up to the MongoDB adapter, which was a few years ago at this point. So where did it continue after that?
Yeah, so after I finished the MongoDB project, Jose asked me to join the Ecto core team, and I did, and stayed on with the project, initially working on it quite a lot. Then recently, Ecto isn't evolving as much. There's not many changes to it, mostly filling in some missing things and then missing functionalities to better integrate with different databases. And then I also started contributing a bit to Elixir itself, to Erlang itself. Especially I was looking all into this performance with the Elixir and then the JSON library. I started looking into Erlang itself, kind of checking out what would be some Elixir-specific patterns that maybe are not optimized as much by the Erlang compiler as they could be. Or are there some other places where the Erlang compiler does something stupid that hurts performance and things like that? And so, and I think contributing to the virtual machine itself was very rewarding. I'm kind of weird that way, that I like some just very low level code. I find it's super hard, but I find it quite rewarding when I finally beat the sea monster and then get it to work, right?
I think calling it the sea monster seems pretty apt. So I guess you're currently unemployed, as you said, but while you were employed and working on all this Elixir stuff, was your company helping, donating time for you to work during work on these open source projects?
A little bit, yeah. So in particular, the company I work for from Denmark, we had an arrangement when I worked a little bit on open source on company time. And then after that, I basically set up my own company and worked mostly as a contractor. So this became a little bit differently, and I worked mostly on my own time. But I think an employer that allows you to work on open source is an awesome thing to have, and something that can help push it forward. On the other hand, I don't think just having a company or an employer saying to all the employees, you can now work on open source, and finishing at that, right? It's probably not enough to get people actually into contributing to open source. It usually has to come from within, from down on the company, and just the task of the employer not to make any problems with that.
Yeah, definitely. Like finding a problem you have that you think like you fix, and then maybe see if you can pull that out into a library is a path we've tried at SmartLogic a few times. So I think that's a good route to start with.
So I want to ask one question that was not on the script, but came up in our pre-interview discussion, which is alternative Beam implementations. You brought this up as something that's been on your mind. Could you, first of all, let's assume I'm a total idiot. What is the Beam? Why would I need an alternative implementation? Why is this important? And why is it on your mind?
Yeah, so Beam is the virtual machine that executes Erlang, right? So it takes in so actually Beam can stand for a couple of things. First is the file format that contains the compiled code, so the bytecode. And then it's the virtual machine itself. The name, I think, stands for Bogdan's or Björn's Erlang abstract machine. So the initial developer was called Bogdan, but now it's primarily maintained by Björn, so the acronym still works. And so this is the primary source for efficiency of Erlang and why we can use all the great features that we have and all of this. And so working on the optimizations and contributing to Erlang itself, I kind of became aware of how it works and some interesting things. And last couple of years, maybe last year or so, there are several alternative implementations that appeared that can execute Erlang code as well. There's this one that's quite old, which is called Erlang, which is an Erlang implementation on top of the Java virtual machine. But I don't think you can get it to work at this point. It was kind of abandoned at some point. But it also showed a couple interesting things that when you make some different trade-offs in the implementation, you can get different behavior in your program and different characteristics that might be more suitable for other environments. So for example, the Erlang implementation in their processes didn't have separate memory like we have on the normal Erlang. And so message passing was extremely fast because you didn't have to copy anything. On the other hand, garbage collector was a bit more annoying because it sometimes had to stop everything, right, to collect the garbage. So those kind of, I think it can be interesting and important for the future of the platform to explore some of those alternative ideas, some of those options, and maybe then look into how we could bring some of those things back to the main implementation if they turn out to be a good idea.
Yeah, and you had also mentioned Atom VM as another one that is trying to run on, I think, very tiny, they say MCUs.
Yeah, so it's another idea. It's another area where Erlang itself can run on some low memory machines, but there is some limit to that. So one would be the Nerves project that runs Erlang on tiny Linux boxes, and then another project in the same vein would be Crisp, which runs regular Erlang directly on top of hardware with some real-time characteristics, also primarily used for some industrial controllers and things like that. But then there are still environments that are more constrained. And so Atom VM targets those. As far as I'm aware, it's still a research project, but you can get some things to work, and it's actively being developed. So yeah, it's another place where you have some different constraints and maybe some different ideas for the implementation. And I'm very eager to see what the results of that would be and some findings doing that implementation. And maybe we'll get something for the main Erlang out of that.
Well, we are just about at time here. And I'm glad that we could finish on a subject that is way over my head. I would love to give you this time, Michal, to make any final plugs or asks for the audience. If you want to drop your social media, where to find info on your libraries, or get involved with any of your projects, or just ask for a contract since you're open to work right now. Sounds like this is really your time. Please plug or shamelessly self-promote or do anything you want with these last few minutes.
Yeah, so I think I'd like to finish with like a call to action to the audience, maybe to get a bit more involved with open source and Elixir in particular, because I think we need more diverse people in our community to maybe push some different ideas forward. I think the most interesting ideas are born where some people with different backgrounds and different approaches come together. So I think this is quite important for the health and future development of the community. And it's actually not so difficult to get involved with open source. It's kind of daunting at first and very, I know that when I sent some first pull requests, I found it very scary in a way to have other people judge my code in a public space. But I think a thing to keep in mind in those situations is that everybody's very grateful for your contributions. And especially with projects like Elixir itself, Ecto, Phoenix, and some other big projects in the Elixir community, the general community around those projects and the maintainers are very friendly and approachable. You can often write to them outside of the main tracker to ask some clarification on some issues and things like that. I know I'm always open to those questions. So yeah, if you want to contribute to open source, but you don't know where to start or something like that, ping me on some social media on Elixir Slack, and I'll try to help you.
And we will link to your social media in the show notes for this conversation. Michal Muskała, thank you so much for joining us today. Really appreciate having you on.
Thank you for having me so much.
And we'd probably love to have you on again sometime. Once again, this has been Smart Software with Smart Logic, talking about Elixir internals. Join us next time for more conversation on Elixir libraries and Elixir Lang. Eric Ostrich is my co-host. I am Justice Ethan. Thank you for listening and have a great rest of your week.